Hey guys, today's April 10th and I'm going to do another LeetCode Daily Challenge. For the past, like 1 or 2 months, I've just been uploading every single day, like these LeetCode Daily Challenges. Yesterday's problem was the first time that I'm not going to make a video about because I don't even understand the problem. Well, after watching and reading many solutions, it's clear that we need to use something that's new to me. It's called digit DP. And I dove a little deeper into what digit DP is, and to me, it's very hard. So this is one of those things that I'm just gonna put in like a to do, like that I want to learn in the future, but I'm not gonna dive deep into it anytime soon. Especially since I I saw that it's more of like a competitive programming technique. I'm, I'm not fast at these at all. I don't think I'm like that's not what I'm trying to do, like competitive programming stuff. And this is definitely not interview material, digit DP wise. So I'm just gonna kind of skip that problem and maybe come back to it in the future. But yeah, usually even if I fail, I just make a video just saying I failed. But this one, no video. Just we'll move on to the new one. Okay, count symmetric integers. 2843. You are given two positive integers, low, high, an integer x consisting of 2 times n digits is symmetric if the sum of the first n digits of x is equal to the sum of the last n digits of x. Numbers with an odd number of digits are never symmetric. Return the number of symmetric integers in the range low, high. Okay, even though this is easy, I'll probably just be ending up doing brute force. But when I was thinking more or like researching more about digit DP, it could be done when there are like some constraints on your number and you're capped at a range from low to high. So I think digit DP would work for something like this. Um, but I'm not gonna go down that path. Let me see if I could do something else. Okay. I think I'm just gonna go like they want the number of symmetric integers, right? So I could just have a count. Um, like what I'm basically doing is just brute force. Uh, so if low was 1 and then high is 100, so we're just gonna go from 1 to 100, and then I'm going to check it every single time. So for I in range, low all the way to high is inclusive, right? So high plus 1. If we're checking the symmetric, oh wait, let's see. If the sum of the first n digits of x is equal to the sum of the last, I think what would be helpful is to just turn it into a string and just call that like string I is equal to the string of I if the length of the string mod 2 is odd, right? They say we just skip odd ones because it's never symmetric. So if it's odd, then we just continue. So now everything in this is going to be an even count. Let's say 1, 2, 0, 3. We want to get the sum of this and the sum of that. So I guess we could calculate half, which would just be the length of the string divided by 2. And then we could maybe just kind of remove like mod 10 divide 10 just to get the last digit. And we just keep doing that for half of it. And then for the other half, we just keep going. So I could just say like first half is equal to 0. It's just going to be like a running sum. And then this can be our first half, and then this can be like our second half. So we want to run it half amount of times, right? So for this in range half, what are we going to do? We always want to take this last digit. So we're going to do I mod 10 is going to be the single digit that we get here. So we want to add that to our first half plus equals I mod 10. And then we kind of want to like remove it so that we're left with 1, 2, 0. And we could do that by doing 1, 2, 0, 3 divided by 10, right? If we divide it by 10, we just get 1, 2, 0. So we just get I divide equals 10. Okay, and then second half is equal to 0 for this in range half. So now we're ready to add our second half. After it did the sum of half of it, now we're just going to do the sum of the other half and keep going. It's the same thing, except we just have second half plus equals to I mod 10. I divides equals to 10. And then we just do if first half equals second half, then count plus equal to 1, just return the count after running from low all the way to high. Cool, so this is brute force, and hopefully it works. Okay, that passed. Let's look at the time and space. So time is O of high minus low. I'm doing this for loop, right? Because we're visiting every single number from low to high. And then we're just running through. And then this shouldn't take a lot of work, right? Because we're dividing by 10 every time. So actually, I don't know the time complexity, but I feel like it's linear. Oh, it's whatever the length of the string is. So we just do high low times length of, let's just say high because it's worst case. And I believe that should be the time. And then for the space, just constant space. Yeah, just constant space should be fine. But yeah, that's about it for this video. Let me see. What is this? Enumeration. Yeah. I guess it's pretty straightforward. You just kind of do exactly what it says. And that's why it's easy. But I might, after this video, I might kind of try to do this using digit DP because it sounds like one of those problems. But again, I'm in this dilemma. I don't know if I should dive into it or not. But yeah, thanks for watching.